Okay, so in this video we're going to be looking at solving limits algebraically. And this is going to be one of the first in a greater playlist of general calculus, which will include stuff like derivatives, integrals, all that stuff. That's how you spell algebraically. All right, so a good way to do this is through three main steps. So step one, let's just list them out here. Substitution. Step two, this is if substitution doesn't work, by the way. Simplification. And step three, which will be trig. Step three is a special case, but it's more so just an extension of simplification using trig identities. And let's begin. Alright, so the first way I like to solve these limits is by using substitution, if I can write that out. And basically, it's just what it says. Just substitute in the value of the limit to the equation and you will get your answer. Let's go through a couple examples. So for the first one, let's do the limit as x approaches 0, 3x plus 5. Now, as per the rule, substitution. So we substitute 0 into x, which will give us 3 times 0 plus 5. 3 times 0 is 0, so that gives us 5. Nice and simple. Let's do another one. The limit as x approaches, let's say 5, of 2 minus 3x. Still pretty simple. Take 5 and put it right into x. So 2 minus 3 times 5, that's 2 minus 15, which is negative 13. Pretty easy, right? Let's do something a bit more complicated. But you should still be able to solve this using substitution. So the limit as x approaches 3 of x plus 2 over x. Still, same rule. Wherever you see an x, you put a 3 there. 3 plus 2 over 3, which gives us 5 over 3. And that's it. So substitution is pretty simple. Wherever you see an x, you substitute in the value that x is approaching, in this case 0, in this case 5, and here it's 3. You plug in values, you solve, and you get your answer. Okay, so the second way, if substitution doesn't work, is simplification. And this basically consists of manipulating the equation so that you can get a solution using substitution. And essentially, so let's take an example and try solving it using substitution. So let's take the limit as x approaches 4 of x squared minus 16 over x minus 4. Now, normally, using substitution, you would say 4 squared minus 16 is 0, x minus 4, 4 minus 4 is 0. Now, since it's undefined, you might be tempted to say, oh wait, this limit doesn't exist. But that's where simplification comes in. So as you can see here, x squared minus 16, that's a difference of two perfect squares. So we would take the limit as x approaches 4, and we would factor this out into x plus 4 times x minus, yeah, that's a plus, so minus here, minus 4, all over x minus 4. Now, as you can see here, x minus 4 and x minus 4, they cancel out, which leaves you with the limit as x approaches 4 of x plus 4. Sorry if my handwriting's a bit messy. Now we can use it, now we can solve it using traditional substitution. So plug in 4 into x, 4 plus 4, which gives us 8. And that's our solution. You want to use simplification when substitution doesn't work out, and find ways for terms to cancel each other out and open up so that the end result doesn't become undefined and gives you a real value. Let's try a few more examples. All right, so let's try another problem using simplification. Let's take the limit as x approaches 2 of x cubed minus 8 all over 2 minus x. Again, to confirm, let's try substitution. 2 cubed is 8, minus 8, that's 0 on top, 2 minus 2, that's 0 on bottom. So now we can go to our second step, simplification. So let's go to the limit as x approaches 2. And you might know that difference of perfect squares simplify, but difference of perfect cubes also simplify into the form of, let me write this at the bottom. So if you have a cubed minus b cubed, that simplifies into the form a plus b times the quantity a squared. Oh, sorry, my bad, there should be a minus right here. A squared plus ab plus b squared. Now let's use that with this example right here. So in this case, a equals x and b equals 8. So, sorry, b equals 2. So we would get a plus b, so, sorry, a minus b, so x minus 2 times the quantity x squared plus 2x plus 4 all over 2 minus x. Let me get rid of the cube thing at the bottom. Now, on first sight, this doesn't really simplify, no terms really cancel out. But taking a closer look, we can factor out a negative 1 from the bottom expression, which will make the equation. Now, make sure to copy down limit notation until you solve it algebraically. It's just a good practice. So on the top, we'll have the same thing. Let's do this, I don't have space. And on the bottom, if you factor out a negative 1, we'll get x minus 2 as well. Cancel out, cancel out. Now, this makes things a lot easier. So the limit as x approaches 2 of this entire quantity right here, x squared plus 2x plus 4, all over, since the negative x minus 2 and x minus 2 cancel out, we're left with a negative 1. Now we can use regular substitution to solve this. So 2 squared plus 2 times 2 plus 4 all over negative 1. That's 4, that's 4, that's 4. 12 over negative 1, which simplifies into a nice whole number, negative 12. And that's our final answer. Let's do one last one with simplification before we move on to trig. Alright, let's do one last example with simplification. So let's take the problem as the limit as x approaches 4 of 2x squared minus 5x minus 12 all over x minus 4. So if we try to solve this using substitution, this is what's going to happen. So 2 times 4 squared, 2 times 16 minus 20 minus 12. 2 times 16 is 32 minus 20 minus 12. That'll give us 0. At the bottom, x minus 4, 4 minus 4 is also 0. Now to move to our second step, simplification. So let's try to factor out the top. The limit as x approaches 4 of, this is going to be a tough one to factor. So what times what equals 2 times negative 12, so 24. What plus what equals negative 5. Um, 8, negative 8, and 3. Yeah, that would work. So we would get 2x minus 8, throw the 2 out as a factor, x minus 4 times 2x plus 3 all over x minus 4. Would you look at that? Two things that cancel out, which leaves us with the limit as x approaches 4 of 2x plus 3. Plug in a 4 using regular substitution. 2 times 4 plus 3, which finally gives us 11. That's our final answer. Now let's move on to trig identities and trig simplification, which will be really useful with any trig functions. So for trig, what you want to do is use trig identities and limits to simplify the broader function into easier terms that cancel out and again give you a real answer. So it's basically an extended version of simplification. Now these are a few of the limits and identities you need to remember to be able to solve them, and they're the sine function and cosine function as well as two basic identities. So let's start off with a simple problem keeping these identities in mind. So let's do the limit as x approaches 0 of 4 sine of x over sorry, let me make that 3x. Okay, so straight off the bat, we can recognize this as being awfully similar to this. So what can we do to make this look exactly like this? So the first thing we can do is factor out a 4/3 from the equation. So by separating those two terms, we get 4/3 times sine x over x. Now what we did here was basically take the 4/3 out and separated it into two different fractions. So in that case, I don't know why that's a 3, that should be a 0. Sorry about that. In that case, we can simplify this part of the equation into 1, and this part remains 4/3. And since there are no x's to plug 0 in, we just take it as it is. 4/3 will be our final answer. Let's do something harder. So the limit as x approaches 0, yet again, of sine squared x over x plus x cosine of x. Now, this is a lot harder to see, but looking at this identity right here, we can rearrange it to get the equation sine squared x equals 1 minus cosine squared x. All I did was subtract cosine squared x from both sides. So that comes in real handy right here, where we can do 1 minus cosine squared x over, and in the bottom we can factor out an x term from both coefficients right here, and we'll get x times the quantity 1 plus cosine of x. Now we need to do further simplifying in recognizing that this is a difference of two squares. So we can simplify that as 1 minus cosine x times 1 plus cosine x all over x 1 plus cosine x. Let me move that to the bottom here. So our final version of the limit will be the limit as x approaches 0 of 1 minus cosine x times the quantity 1 plus cosine x all over x 1 plus cosine x. Now we can see that these two cancel, leaving us with the limit as x approaches 0 of 1 minus cosine x all over x. Now, this is awfully familiar. It's actually the exact same thing as our identity up here, and we know that that identity equals 0. So in the same sense, we can set this entire thing to 0 and have our final answer right here. Let's do one more using sine and the limit identities. Let's clear some space. That works. All right, let's do one last trig function. So let's try the identity using sine as well as this one right here. So the limit as x approaches 0 of the function sine 4x all over 4x. Now it might be tempting to take the 4 out and simplifying it as we did in the problem before, but unfortunately we can't do that here because 4x is inside the sine function, it's a part of it. But that does let us use another identity. If we write this another way, we can say sine of 2 times 2x, where 2x is basically acting as our solitude x right here, all over 4x. And we can simplify that even further using this identity, which makes it 2 sine. In this case, x is 2x. So 2 sine of 2x times cosine 2x, all over the quantity 4x. And let's add our limit definition here. Finally, we can start substituting in values and factor values out as well. So let's factor out a 2/4 or 1/2 and put it outside the limit. So 1/2 times the limit as x approaches 0 of sine the sine of 2x times cosine 2x, again all over 4x, well x now. Now this brings us one step closer. All we need to do is repeat the same process, except this time it's much simpler because we have sine of 2x right in front of us. So let me move up again. So we have 1/2 times the limit as x approaches 0 of 2 sine x cosine x cosine 2x all over x. We can factor out another 2, which will basically erase the 1/2 from the equation. So we get rid of that, and we get rid of that as well. And we have our identity right here. This will simplify to a 1, which leaves our final equation as the limit. Let me just put that line down instead. As the limit as x approaches 0 of 1, since we simplified that, times cosine x times cosine 2x. Now this becomes a whole lot simpler, and we can just use regular substitution to solve our equation. 0 there and 0 here. So cosine of 0 is 1 times the cosine of 2 times 0, which is also the cosine of 0, is 1, which leaves our final answer to be 1. And that's basically the furthest extent you'll have to use trig identities at this level. And to do well, you need to remember these 4 identities and make sure that you simplify and find new ways of writing the same terms in order for terms to cancel out and leave you with a real answer.